So far, you have looked mostly at situations involving particles. This means you can ignore rotational effect. This allows you begin to model objects as rigid bodies to consider the size of the object as well as where forces are applied. R cross F equals tau. R cross F equals tau. R cross F equals tau. The diagram. About the point P, results in moment about the point P, clockwise, anti-clockwise. Moment. with the tension in the string at B 1.5 times the tension in the string at A, 4 times the tension in the wire at A. Kilogram and length 5 meter rest horizontally on supports at C and D, where AC equals dB equals 1 meter. A man with a mass 80 kilogram stands on the beam at E. The magnitude of the reaction at D is twice the magnitude of the reaction at C. ATG Newton. So if I take a moment about point C, then the distance from C to point the middle center of the road would be 1.5 meter clockwise. So 1.5 times 40g, and let's say the distance from C to the person is x, then the moment of the person at that point would be x times 80g. So x times 80g clockwise, and that must be equal to n reaction at D, and the distance would be 3 meters, so n times nd. And we also know that it is linearly equilibrium, so nc plus nd equals 120g. This $60g plus 80gx over 3 equals nd, and nc equals 120g minus nd, that equals to 360g minus 60g minus 80gx over 3. Thus, it equals to 300g minus 80g x over 3. And we want to know that we are given that nc is ND is 2 times MC. There's 60G plus 80GX equals 2 times MC. That means 600G minus 160GX. So we can cancel out G and divide by 10. Then we have that 24x equals 54. Thus x equals to 54 over 24. That equals to 18 over 8. 9 over 4. So 1.25 meter from C. 2.25. So it's far from its distance of AE must be 3.25. Two particles P and Q of mass 4 and 2 kg respectively move in the same direction on a smooth horizontal surface with constant speed of 0.2 meter per second and 0.1 meter per second respectively at t equals 0 seconds. P and Q are 0.8 meter apart. P, Q, and that have 4 on the smooth plane, 4 kg, 2 kg, and have a distance of 0.8 meter apart. And have a speed of 0.2 meter per second and 0.1 meter per second. And the thinking of that, the thinking of in terms of Q, P is approaching to Q with speed of 0.3 meter per second. So that means the time taken to be collide would be 0.8 over 0.3, which is 8 over 3 seconds. Or that means that the distance of P moved is 0.2 times t from the origin when we take the origin as the point of P, and the displacements of Q might be 0.8 plus 0.1 t. This, if we make it equal, then t equals 8 seconds. After the collision, the speed of P is halved, and both P and Q continue move in the same direction. So the momentum, linear momentum would be conserved. That means 4 kg times 0.1 meter per second plus 2 kilogram times speed v meter per second equals 0.8 plus 0.2, that means 1 kilogram per meter per second. So we have v equals 0.6 meter per second. Velocity time graph shows the motion of the train during a particular journey. Describe what is happening between t0 and t1. The train is accelerating with a constant acceleration, and between t1 and t2, the, the train just keeps its velocity with no acceleration. Between t2 and t3, the train decelerates with the acceleration of I don't know. Anyway, T1 and T2. So because it is a velocity times graph, the area under the graph would be the distance, displacement it moved. So displacement. So that means 80 kilometer per hour times T2 minus T1 hour equals 120. That means T2 minus T1 equals 1.5. So each unit has 0.5 hours, and it takes like 1, 2, 3, 4, 5, 6, 7, 8 units. So it might be 4 hours to complete the journey. Total distance traveled by the train might be the area under the graph as well. So that means 1.5 plus 4 base length of base, its base, which might be 5.5, and the height of the trapezium, which is 80. So 80 times 5.5 divided by 2, so 40 times 4 times 55, 220 kilometers. Non-uniform road AB of length 4 meter and of mass 20 kilogram rests on two pivots P and Q that are 0.5 meter from A and B respectively. So it looks like a mass of 50 kilogram is placed at B, causing the road to be on the point of tipping around Q. So it's about to tipping around. It's about to tip around. That means the reaction on the point P is 0. So there be reaction only at point Q. Let's say this RQ. And we don't know the location of the center of mass. So let's say just it's far away from the point A by x meter from the point A. So it exists 23 Newton, and there would be 50 G Newton exerted on B. So the first thing is that it is linearly equilibrium. It's in the linear equilibrium. That means RQ equals 70G. And if I consider the torque about the point B, then RQ, there would be a torque of 0.5 times 70G clockwise at point Q, and 20G, 4 minus X times 20G anti-clockwise on the point of center of mass. So we can make it to be equal and cancel 10G. Thus 4 minus X equals 7/4. Thus X equals 16 minus 7. Thus 9/4 beta. Work out distance of the center of mass from A. That is 9/4 meter from A. The mass is removed from B. Now there is no. Work out the reaction at P and Q. So consider the linear equilibrium, then RP plus RQ equals 20G Newton, and considering the torque about point of center of mass, then torque at P would be 7/4 times RP clockwise and 5/4 times RQ anti-clockwise. That means RQ equals 7/5 times RP. There's RP plus 7/5 RP equals 12/5 times RP equals 20G. There's RP equals 100G over 12, 50G over 6, 25G over 3, 25G over 3, and RQ then becomes 35G over 3. Particle P of mass 3 m kilogram is attached by a light inextensible string to a particle Q of mass m via pulley. Particle Q is held at rest on the ground while particle P is at height of 1.2 meter above the ground. Particle Q is released. So there is a pulley, and the particle P is hung around above the ground by 1.2 meter, and Q is held rest on the ground, which have a massive M, while Q have a massive 3M. Thus, the pulley will rotate around, rotate anti-clockwise. Work out the acceleration of particle Q and the tension in the string. So if I resolve all the forces exerted on it on this system, respectively, there is a gravity exerted on the P, which might be 3mg, and tension T above, tension T upward on Q, that would be equal as the string is light, and of course there would be a gravity weight of mg on Q. There's the system of this connected particle will have net force of 2mg downward, anti-clockwise. So net force would be 2mg, and net mass, sum of the mass would be 4m. So 2mg equals 4m times acceleration a. This a must be 1/2 times g. Show that the time taken for particle P to hit the ground is 0.353 seconds with 3 significant figures. So we know that it starts with particle P moves starting with rest. So the initial speed of T would be 0, and the distance it moved can be written as in the formula S equals 1/2 times A times T squared. That means T equals 2AS and the square root of it. We know that 2A equals G here, and S equals 6/5. A sledge A of mass 1,200 kg is connected to a second sledge B of mass 300 kg by an inextensible tow bar. The sledge is set on a rough horizontal track that has coefficient of friction mu. So if I draw the situation in the diagram, there's a sledge A here, sledge B connected to sledge A, which have 1,200 kg and 300 kg. Thus having a weight of 1,200 G Newton and 300 G Newton, and there is no vertical movement or vertical net forces, so have the same normal reaction of 1,200 G Newton and 300 G Newton respectively, and know that tow bar is inextensible, so there would be tension, or that could be stress. However, let's just suppose it's tension this time. And if the tension gets a negative sign, then we can think of it as a thrust. So that doesn't matter. There's tension, and tension should be equal as the tow bar is considered light. Okay, so I think tow bars have no masses. We don't need to consider the mass of a tow bar. So sledge. Sledges sit on rough horizontal track. Forward force of 550, 509, 5,940 Newton is applied to sledge cruising. So forward, it might go to the left. By the force exerted on A, which have the amount of 5,940 Newton, and there would be friction. Mu times 1,200 G and mu times 300 G. And the net acceleration must be 2 meters per second squared. Thus, just consider it as a whole system. It has a mass of 1,500 kilograms. An acceleration of 2 Newton, 2 meters per second squared. Thus, we have to consider the net force. So 5,940 minus mu times 100, 1,050, 500,000 Newton. Thus, mu equals 5,940 minus 3,000 over 1,500. That is where's G? Oh. That might be 1/5. Tension in the tow bar. So now consider the respective the particle, sledge. So considering the sledge P, then we have the net force of T minus 16 G and mass of 300 kilogram and acceleration of 2 meters per second squared. Thus T equals 600 plus 60 G. That might be similar to 1,000 Newton, 1,200 Newton. Using part A. So we have assumed that tow bar is light. After 5 seconds of tow bar snaps, so the resistance remains the same. Look at how far sledge B travels before coming to rest. So after 5 seconds, because it had a 2 meters per second squared of acceleration it might have the speed of 10 meters per second. So it has 10 meters per second. Initial speed might be 10 meters per second, and acceleration after it gets snapped is acceleration, let's say a prime equals 300 over minus 16g, there's 5 over g. So 10 minus 5 over gt equals 0. There's t equals 2g. Leaves point A and sails with velocity 5I plus 4j kilometer per hour. After 3 hours, it reaches point B where it changes direction and sails with velocity after 4 hours. So 5I plus 4j times t speed. So we've got to work out the distance traveled. So 5 plus 4 times 3 hours, and that equals to 15 plus 12j. There's 15 squared, 12 squared, and the square root of it might be distance from A to B. And 8 minus 8I minus 2j times 4 equals 32I minus 8j. And 32 squared plus 8 squared, and square root of it might be the distance from B to C. So 15 squared plus 12 squared, and square root of it plus 32 squared plus 8 squared, and square root of it over 7 hours might be its average speed. So let's think of the displacement of the C with regard to A. That is, let's say just A as, let's say the A as a region. That means C must be 3 times 5 vector 5 4 plus 4 times 8 negative 2 is 32 plus 42, 47, 4. There's the distance. It would be 47 squared plus 4 squared and the square root of it over 10. This would be the time taken. If particle A of mass m sits on the slope that is inclined at an angle of theta to the horizontal, the particle is held in equilibrium by two forces. One of the forces has magnitude p and acts horizontally on the particle. So it might be the force p acts like this, or it could be the negative sign, but the other force has magnitude p and acts parallel to the slope. The thing is that we don't know the direction of each forces, so we might set one direction, and if we get a negative sign, that implies that the direction of the force might be converse. So let's suppose the other force has this direction and take it p prime. But the problem is that we don't know if this slope is rough or smooth, but I think I guess this is smooth. There would be m, the weight mg here. What about p acting like this? Then theta must be very, very steep. Okay, so if I resolve this force parallel to the slope, then that must be p prime plus p cos theta equals mg sine theta. Or that could be p prime minus p cos theta, because we don't know the direction of the force p. And we are resolving the forces vertical to the slope, then we might get mg cos theta plus p sine theta equals some normal reaction, but that doesn't matter. So we don't need to consider the vertical resolve. So um, P equals mg sine theta over 1 plus cos theta. This is one case, and if the horizontal force P is exerted in the opposite direction, then we can say that if I resolve the force parallel to the slope, then it might be P equals P cos theta plus mg sine theta. This, and we now have to consider the vertical component of the forces, as if P is very, very great, that it could exceed the weight of the particle. So R resolving it, then P sine theta plus normal reaction R, let's say it, N mg cos theta. And we've known that normal reaction can not be should be greater than 0, but um, so mg cos theta minus p sine theta, that equals to n must be greater than or equal to 0, and p from the first equation we get p equals mg sine theta over 1 minus cos theta. Thus, this means that mg is greater than or equal to p tangent theta. This must be, and that equals to mg sine theta over 1 minus cos theta times tangent theta. So we can cancel out mg on each side of the inequality, and that means 1 minus cos theta must be greater than or equal to sine squared theta over cos theta. Thus, cos theta must be greater than or equal to 1. Cos theta must be greater than or equal to 1. That means that theta must be 0. That is the only way that the particle can be stay in equilibrium. So show that the normal reaction between the particle and the plane is mg. So R must be mg's cos theta plus mg sine squared theta over 1 plus cos theta, which might be p sine theta, p sine theta equals mg sine squared theta over sine squared theta times 1 minus cos theta. Thus, if we sum those two forces, then it will be equal to mg. Yes. Given that P equals 0.25 mg and theta equals 30 degrees, find the initial acceleration of the particle. In a football competition where every round played is a knockout match, Draw leading to a replay is not an option. How many matches will be played in the competition in total if there are n teams? What does it mean? Draw leading to a replay is not an option. So draw means draw, right? So is that what is the difference with tournament? Double elimination tournament. In a football competition where every round played is a knockout match. So I wonder if this can be divided by two. I mean, if n is an odd number, then like four, there's 8 teams, then four, four, and four can be divided into two, 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 two. But the problem is that if eight, if there is a 10, then it might be divided into five, five, and then two, two, one, two, two, one. I don't understand how it is. So firstly, there will be 5 games, and each of winners will have a match again. Like this. So this means that we can sort out the case here where n is just have a prime factor of 2. So that means 2 raised by the power of k, where k is just arbitrary positive whole number, and or n can be just an even number that contains a odd prime number as a prime factor, and n just itself can be an odd number. There is too many cases that I have to consider. So I think this sorting out method is not a good idea, as n is if even if n is odd number, we can just take one team out, like then we can make n minus one as an even number, but we have to again sort out this, as this can be two raised by the power of k, or two, or it also possess some prime factor, so odd prime factors. Then we have to sort out this again. Then it will continuously require sorting out. So I don't think this would be a great answer. How many how many matches will be played in the competition in total if there are n teams? So the thing is that we don't need to think of um, oh, I think the East um, I think the gist of this question is that total number. So each game there will be one loser, and loser will be just cancelled. So that means if there are n minus n teams, then n minus one teams should be cancelled. So there should be n minus one games in total. There must be n minus one matches played, as at the end of every match, one team is sent out of the competition, and of course there is only one winner at the end. In how many ways can two an opponent be paired in the first round of tennis competition? Can you come up with a more succinct expression for your previous solution? So I just want to order all of the all of the teams in order, and like A1, A2, A3, and so on to an minus two n minus one, and two n minus two, and A2n, and we make a team for each two orders. Like we divide for each team multiple of two, then there'd be a team. However, for each for each team, there would be n minus there is two there would be double counted, like A1 and A2 can change their order, but they should be still they should be still um, um, match. So the result is same. So that means for every team there is two factorials times double counted numbers. So that means there should be two factorials raised by the power of n double counted matches. So if I if I just arranging in order, make different lines. I can I can arrange them in order. So the that number of cases to arrange them in order might be 2n factorial. So this can be rewritten as 2n factorials over 2 raised by the power of n. Okay, um, so this is just, I believe that this is n factorials squared, because no, it's not. If I gave you a large value for n, you could then use your calculator to calculate the answer quickly. Well, there is a factorials in the calculator, but what should I do? I can, I can, I can add. No, no, no. Mm, mm, wow. No, 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 not this, not this, because it is not a proper way. Because if they, oh, and the one more thing I forgot to say is that if there is A1, A2, A3, A4, and if they look like A1, A2, A3, A4, then those group can be reordered, but that doesn't matter. So we have to divide them by n factorials. So yes, what should I do with this? Um, I believe this is something like coefficient of function. I just guess like that. Yeah, I'm guessing like that. So it could be some coefficient of polynomials. Um, I can get a hint from that too. Why is there two n factorials? Hmm, I don't need to order them, right? Or just simply how to how to sort them. How to sort them. Um, Large value of n could you could then use your calculator to answer quickly. Uh, but I don't think that it could be a polynomials coefficient of polynomials because there is a factorials on the numerator, and I've never seen some some coefficients that have numerators with factorials. So I think I can't figure out some polynomials that have. Then I have to think if there's. I have to figure out some new approaches to this. What should I do to an opponent? So I want to choose. To n c n. So they would have. So let's say that they're ordered in the normal. So we can order them with any rules, like we can force them to line up in order of height. So they'll be given anyway the number. So you don't have a line. So if we choose if, if we choose n people from two n peoples, then they'll have their own order, and then that means two n c n. Now they have to, and the now remained other people should should make a line. So n factorials. Then we have a match. But now what we have to consider is that if they're double counted, so the person a person who was selected at first can be selected, doesn't select it, but can have a same opponent. Um, wow. For the it's player one, they can be paired with two n minus one other people. Next, relabel the remaining players. One player again. This is not something that can be evaluated quickly, and some messing around with factorials and powers to will lead to more toxic expressions. (10시간) 채우는 게 목표였는데 10시간은 또 안 된다. In how many ways can two AND opponents be paired in the first round of a tennis competition? Can you come up with a more succinct expression for your previous solution? Firstly, I want to I want to arrange all of the tennis players in order, all of the tennis players, two and tennis players in order, and that has the total number of cases of two and factorials. Then then I will divide into two people in order. Like if tennis players A1, A2, A3, A4, and so on to A2N is arranged in order, then I'll make a group with A1 and A2, A3 and A4, A5 and A6, and A7 and A8, and so on to A2N minus 1 and A2N, like this. Then there'll be a match. They'll have a match. Then this is not the end, as if they are arranged like if the order in their group is altered, the result is the same, as they'll have anyway match together. That means A2, A1, A3, A4, A5, and so on have the same result with A1, A2, A3, A4, A5, and so on. That means in each group they have um, they have two cases in order. Like so they're double counted, and there are n numbers of double counted matches. So that means the double whole number of double counted cases are 2 factorial raised by the power of n. Thus, we need to divide them and divide 2n factorials by 2 raised by the power of n. But this is not the end. Each group can be altered, like A3, A4, A1, A2, A5, A6, and so on is equal to A1, A2, A3, A4, A5, A6, and so on. Because the order of the group doesn't matter. There's we can alter the order of the group. So the order so we need to divide the number of cases by the number of cases that the group can be arranged. That means we need to divide 2n factorials over 2 raised by the power of n by n factorials. That means the number of cases we are looking for is 2n factorials over 2 raised by the power of n times n factorials. How many distinct tessellations of the plane use only regular polygon? Tessellations? What is tessellation? Um, so the regular polygon should not be all the same, right? I mean, we can use triangle. Oh my god. In how many ways can two N opponents be paired in the first round of a tennis competition? Here's my answer. First of all, I want to arrange all of the 2N tennis players in order, and that requires that have the total case number of 2N factorials. And I'll make a group. So I'll make a group for each two players in order. Like if A1, A2, A3, A4, and so on to A2N is arranged in order, then A1 and A2 becomes a group, A3 and A4 becomes a group, A5 and A6 becomes a group, and so on. So the group means that they will have a match. However, there will be double counted, multiple counted cases number. Like in a group, players can alter their order. Like A2, A1, A3, A4, A5, A6, and so on will have the same result with A1, A2, A3, A4, and so on. Because A1, A2, the fact that A1, A2 have a match doesn't change. So each group can alter their order. So there will be two multiple counted cases, a number of cases for each group. Thus, we need to divide 2n factorials by 2 raised by the power of n. However, this is not the end, as there are still some multiple counted cases. Each group can change their order. I mean, A1, A2, A3, A4 can change it into A3, A4, A1, A2, because the order of the group doesn't matter. The gist point is that they will anyway have the match, and the order of the group doesn't matter. So we can and there the number of multiple counted order must be equal to the number of cases that of arranging those n numbers of group in order, that which is n factorials. So we need to divide 2n factorials over 2 raised by the power of n by n factorials, which will result in 2n factorials over 2 raised by the power of n multiplied by n factorials. On one regular polygon. So obviously rectangle, sorry, square can be used. Yes, square can be used. What about the angle, one angle of the regular polygon? Total case number of 2n factorials. There are 2n factorials way to arrange all the players. Explain how players are grouped instead of A1 is paired with A2 to form a group, A3 is paired with A4 to form another group, and so on. This arrangement counts some pairings more than once. This arrangement counts some pairings more than once. final formula explanation. So we need to so when I have to think of the internal angle of regular polygon, I first think of the external angle first, which is, so if we are considering the n regular polygon, then the external angle must be 360 divided by n. So the one external angle would be 180 minus 360 over n. That is the internal degree of n regular polygon. And to make a tessellation, they must be that internal angle must be a factor of 360. Like, if they are not, they cannot join. They cannot join at one point. So there will be some gap between when they're joined together, or there will be some overlap between with amongst them. So 180 minus 360 over n should divide 360. And we need to think of this. When n is 2, when n is 3, then it becomes 60. So 60 divides, as 60 divides 360, so n equals 3 can be a tessellation. What about 4? When I put n equals 4 in the expression, then it becomes 90 divides 360. There's n equals 4, which means square can be a tessellation. What about 5? 5 cannot be, as 360 over 5 equals 72, and that means internal angle of the regular pentagon would be 108 degrees. However, that can't divide 360, so pentagon cannot be tessellation. What about n equals 6? Hexagon can be, as when n equals 6, then 360 over 6 would be 60, and that means internal angles will be 112, 20. So that divides 360. So yes, it can be. So there is, so let's say 100 minus 360 over n times k, where k is an integer, positive integer. That equals to 360. So that means 100k minus 360k over n equals 360. Does 108, let's divide the left-hand side and the right-hand side, both of the sides of the equation by 180, which will give us k minus 2k over n equals 2. And let's multiply n on each side of the equation, which will give us n minus 2 times k equals 2n. Lastly, we can write k equals 2n over n minus 2, right? Or we can write it as k plus k minus 2 times n equals 2k. So n equals 2k over k minus 2. So anyway, we have to think of now. Think of when n minus 2 divided 2n can be an integer. N equals 3 is okay. N equals 4 is okay. What about n equals 5? No. N equals 6? Okay. N equals 7? No. N equals 8? No. N equals 9? No. N equals 10? 10, 10, 10 no. N equals 12? No. N equals 14? Um, no. N equals 16? No. N equals 18? No. N equals 20? Wow. I thought 12 was okay. What's the problem with it? Regular polygon? Why are there only 5 platonic solids? What is platonic solids? So the one external angle would be 1. The internal angle can be calculated as if they cannot join at one point. For a regular polygon to tessellate, its internal angle must evenly divide. If it isn't, polygons will either leave gaps or overlap when they are joined together. Minus 3. Solid made of triangle must have 4, 8, or 20 faces. So I cannot make a 3D shape I cannot make a polyhedron by polyhedron which are of which vertices are made by um, only two joined triangles because two joined faces. So there must be at least three to uh, make it three-dimensional. So um, if three triangles are joined together, then equilateral. Well, they're just equilateral triangles, and they would be like they would sound like this. So if I let's say that it is an regular polygon, then vertices must be they're um n faces. That means it's just vertices of triangles must be 3n just individually. However, they will meet at each point. The three triangles will meet at each point. So we need to divide it by three. So vertices must be n. What about um, the edges? Its triangles have three edges, so just individually there would be three n edges. However, two triangles join together to make one edge, so we need to divide them by two. So 3n divided by 2, there's um, n minus 3n over 2 plus n. So n over 2 equals 2. So n equals 4. What about there? There are four equilateral triangles to make a one point. Then there are there are n faces on the tetrahedral, polyhedron, and vertices would be just four n vertices individually, considering the individual triangle. However, three n vertices. However, four triangles meet together to make one vertex, so it need to be divided by four. So total number of vertices will be 3n over 4. What about edge? There are 4n edge on each for every triangles individually. However, they need to be divided by 2 as two triangles meet together to make one edge. So E would be 2n, 3n over 4n. What about 5? We can do this again. Why are there only 5 platonic solids? So let's think of this. Let's draw this first. So 2n over n minus 2 equals 2 plus 4 over n minus 2. So if I draw this on the coordinate, just considering that n is a positive real number, then it must be look like this. So let's put n equals 4, then the answer must be 3. Thus, for every integer greater than 4, k cannot be a positive integer. So when there are only two integer n, that makes 2n over n minus 2 and a positive integer. So 3 and 4 can be a candidate for those number n, and then we can prove that 3 and 4 makes or correspond 3 and 4 is corresponds to 4 and 3 respectively. So they can be a tessellations. The numbers. Here's the question. The numbers 1 to 1,000 are written on the blackboard. You will randomly choose two numbers, A and B, from among them and replace them with their difference. You continue to this process until you are left with a single number on the board. It is possible for you to be left with the number 1. Here's my answer. Okay, so I just randomly choose two numbers. Then that could be 999, 998. So for the last part, we have to, there should be only two numbers, n plus 1 and n. That means, so the gist of this problem is thinking of if it is possible that n plus 1 and n can be remained. What about then? N plus 1 can be made by some integer that k plus n plus 1, and n can be made by l plus n. So, oh, this is quite hard. Wow. A and B, among them, you can continue this process until you are left with a single number on the board. So, wow. Is that possible? I can't find the reason why they're not possible, but just intuitively it's not. But I need to prove it. So I just want to say that it is possible, and because I just intuitively feel that it must be even number, because there are 500 matches at first. They can all have 499, and then it must be 0. So I can think of the sum first, but I don't know why I have to think of the sum of the all numbers. Difference. Oh my god. There would be 500. No. 1. When I add all of the number at first, okay, so when I add all of the number at first, then they must be that's 2 from 1 to 1,000. it must be an even number. Then let's so uh, so I didn't do anything. So let's say n equals 0. Then all sum s is even. What about n equals 1? Can I make it even? If I choose even number and even number, that must be even, right? Then their difference must be even. So s must be even. Then s must be even because even number minus even number minus even number plus even number is even number. What about how can I make it odd? To make it odd, then I'll have to choose one odd number and one even number. But even minus odd minus even plus odd is even. So s must be still even. Yes, so for n equals 1, s must be even. I think I can prove this. N equals 2, then it must be even. Because when the sum of the previous stage is even, then the sum of the next stage must be even. So it's like mathematical induction. Yes. If I color three faces of cube red and the other face is blue, how many distinguishable colorings are there? So cubes are symmetric at first. So I can place it with any order, just any way that I like to. Then it doesn't matter if I set the bottom as a red. So here's red. The bottom is the red. Now it's not symmetric if I rotate it vertically, but it's still horizontally symmetric because if I rotate it this way, it's still symmetric. And we have three colors, so no matter if I color red color, no matter how I color the top faces, there would be at least one faces in the side of the cube that have red color. So let's say here's red color again. So there is no any symmetry for now. So we can number its faces 1, 2, 3, 4. So except among these four faces, one of them must be colored by red and the other would be colored by all of the other must be colored by blue. So there is only four cases. consider the total of all remaining numbers on a blackboard, it can be shown that the parity of this total is invariant under proposed operation, and as it begins an even quantity, then it's possible to achieve the desired scenario. Integral of cube root of tangent x over sine x plus cosine x squared. Sine x plus cos x squared with respect to x from 0 to pi over 2. But I want to draw at this function firstly. How can I draw this? It's not a, well, it is symmetrical. However, I want to draw firstly sine x plus cos x, but this is equal to square root of 2 times sine x plus pi over 4. Thus, it might look like sine x looks like this, and this should be translated by negative pi over 4 along the x-axis. So it might look like this. Is the 2 pi, the pi minus pi over 4. So 3 pi over 4, 7 pi over 4. And let's square this. If I square this, then it's might have this shape. So if I square it, then its graph must look like this. It have a zero value at 3 pi over 4, 7 pi over 4, and so on. Negative pi over 4. And if I take a reciprocal, and the maximum value of this will be 2. If I take a reciprocal, then 0, when it tends to 0 from upper side, that it will tends to positive infinity. And when it becomes a value of 2, it actually becomes a half, 1/2. So this is y equals 1 over sine x plus cos x squared. So let me draw this again. So here,
this is 1 over sine x plus cos x squared. And tangent x must look like just this shape. When it becomes 0, but it wouldn't have any value. So I don't know whether it would have I don't know if it would have some local maximum or local minimum, but it starts from 0 to infinity between 0 and pi over 2. So this is the shape of the graph, and to integrate this, I think I'd have to take I substitute this. So let's say that tangent x equals s over c cube squared, cube root over s plus c squared with respect to x from 0 to pi over 2. And let's divide each denominator and numerator by cos squared. Then I'll have t plus 1 squared divides t raised by the power of 1/3 raised times sequent squared x with respect to x from 0 to pi over 2. So this is equal, as sequent squared x is a first derivative of a tangent, we can just say that it is equal to 0 to positive infinity t plus 1 squared. Yes. So what should we have to do? Partial, or what should we do? Wow, I think I can take integrated by parts. So it must be t plus 1 squared 3 over 4 times t raised by the power of 4, 3 minus right? But I think this becomes more complicated, so let's integrate t plus 1 squared first. Or let's say let's shift this a bit. One to infinity over t squared divides t minus 1/3 to t minus 1 to 1/3 with respect to t. Then I can say that is equal to 1 to infinity 1 over t times t squared t cubed minus 1. Am I right? With respect to t. I don't think it was a good idea to do that. Wow. What should we do here? Oh. I don't know what to do here. So. Just honestly, I want to use a Taylor series here, but I think that's not a good idea. Because I'll have to add every, I have to infinitive terms. That would result in some errors. So dealing with infinity is not that intuitive way to do this. Oh, what should I do? But the thing I've come up with is I can consider another this or something else like this. So can I come up with other functions? What about I take this dt equals this. This one squared equals 0 to infinity. One plus s squared 1 plus s is we might have 0 to yes. So that means we can write it as oh, is that possible to solve? 1/2 of 0 to infinity t squared dt. Now what can I do? Take t. Now I can t equals a, and then 1/3 t dt equals dA. That means 1/3 dt equals a squared dA. That means 1/2 0 to infinity a plus 1 over a cubed plus 1 squared times 3 times a squared dA. Right? Yes. Now then, I can write this as 1/2 0 to infinity 3/2 a cubed plus a squared. No. A cubed plus 1 squared dA. Can I use a partial integration for this? Is this possible? 뭔가 이 부분에서 영감을 잘 얻어서 B까지는 되게 잘 온 것 같고 이게 정석 풀인 것 같긴 한데 여기까지 오는 것도 너무 당연했고 이 부분을 어떻게 푸는지가 좀 관건이었던 것 같은데 그거를 못 생각해요. 이거 어렵다. 이 부분이 너무 어려웠습니다. 결국 포기. 어려워. 메카닉스를 최대한 오늘 2까지 좀 보자 라고 생각을 하고 계획을 짰는데 아침에 책을 안 들고 왔어. 그래서 못했다. 책을 안 들고 못했고 뭐 그렇게 됐습니다. 오늘 시작 시간이 막 엄청 빠르진 않았거든. 근데 지금 뭐 원래 3시 반에 끝내야 될 뭐 4시에 해버려서 4시까지 해버려서 벌금은 내야 되지만 그래도 지금 시간이 꽤나 많이 했어요. 오늘 9시간 51분 56초 집 가는 것까지 하면 10시간이거든. 사실 10시간 채운 게 옛날에 자기소개서 쓸 때 한번 채운 거 빼고는 순공수로는 처음인 것 같단 말이야. 물론 오늘 뭐
진짜 그게 순공부냐 물어보면 아니지. 아닌데 내가 공부학사고 한자고 있었던 시간을 다 생각하면 물론 중간에 막 좀 놀긴 했지만 이렇게 안 해도 노니까 어차피. 그래서 꽤나 오늘 열심히 했다. 기분이 좋네요. 4시에 마친 거 빼고. 그래서 집 가서는 진짜 빠르게 자자. 진짜 빨리 자고. 어차피 어제 내가 5시에 잠들었거든. 물론 학원에서 어제 완전 잤지만 5시 반쯤에 잠들었구나. 그리고 막 악몽 꾸고 막 난리도 아니었어 어제. 근데 또 늦었네. 그래서 좀 오늘은 잠을 좀 푹 자야 될 것 같아요. 이렇게 피곤이 누적되면 진짜 너무 힘들어. 빨리 가야지. 보통 근데 7시쯤에 인터뷰를 할 건데 7시에 인터뷰를 하면 그게 10시고 지금 우리가 24시에서 4시간 더 해서 28시 그러면 9 빼면 21시니까 21시에는 면접을 안 할 거 아니야. 해봤자 면접 시간이 언제지? 면접하는 시간이 아직 곧 나올 것 같긴 한데 한 이틀 안에 나오겠지 면접 시간은. 아니 월익대학교는 짜증나 그냥. 월익대학교는 오늘 갑자기 메일 와가지고 저번에 한 몇 주 전에 보냈던 사항 이제 와서 말해주고 장학금 주는 것도 아니고 해정을 다 해줬습니다. 힘들 수밖에 없어 남은 게. 그래도 얘네는 캠브리지는 가장 마음에 드는 점은 확실히 일 잘해. 일단 컬리지별로 나눠서 그런지 대학 본부는 일 잘하는지 모르겠거든. 뭐 못하는 느낌은 못 받았지만 막 잘하는 느낌은 못 받았는데 컬리지들 각각 물론 컬리지별로 다르겠지만 왜냐면 컬리지 애들이 잘하는 컬리지랑 못하는 컬리지 스스로 느꼈거든. 근데 피트하우스 같은 경우에는 일 잘하는 게 느껴져. 그래서 뭔가 되게 체계적으로 잘 안내를 해주길래 아마 면접도 내일 모레 안에 나오지 않을까 그렇게 예상이 됩니다. 아니 대학 학사관리팀이 일 못하는 거는 사실 만국 공통이라고 생각했어요. 대학 학사관리팀은 항상 엉망이라고 생각했는데 여기는 학사관리팀 분들이 학년끼리 다 옥스프리트야. 물론 학사관리팀은 아니겠지. 정확히는 입학사령관님들이신데 그래도 어떻게 입학사령관님들이 우리보다라고 하면 안 되겠지만 당연히 우리 평가하시는 분이니까 학벌이 좋겠지만 그래도 다 옥스프리트야. 입학사령관님들이. 뭔가 일 잘하는 게 있게 돼서 기분이 좋다. 뭔 소리 하는지를 모르겠다 내가. 수고했습니다. 어떻게 꺼 이거? 안 보이는데?